Hey guys, time to move on to the next great adventure, inverse trig functions. In here you'll be able to evaluate and graph inverse sine functions, evaluate and graph other inverse trig functions, and evaluate compositions with inverse trig functions. Sounds like fun. Okay, so inverse sine function, if you remember with inverse, it means you interchange your x's and your y's. So that's what we're thinking about back in the day. So what I want you to think about is we need it to pass the horizontal line test. So in order for it to have an inverse, it has to pass the horizontal line test. And if you think about a sine function as what we're looking at right here, you'll notice that it will not pass the horizontal line test, because if I do a horizontal line, it's going to hit that graph too many times. So what I have to do is I have to become the king and queen of this function. And by that, I mean I have to put rules. So I have to make a rule that says I only want part of my function so that it will pass. And so you'll notice what they did is they take the part that is closest to 0. So we restrict the sine function going from negative pi over 2, which is right here, which is right here, negative pi over 2 to pi over 2. That's the only part of this function we want. That way we can have an inverse function. Now, remember, inverse function means interchange your x's and your y's. So that means your sine's domain and range are going to get flipped because this is x and this is y. So when you're talking about your inverse function, your range is going to be your domain and your domain is going to be your range. So it literally takes your function and just kind of flips it. And one other thing I want you to see, this is how you write inverse function. You can also write it like this. That's probably what you learned in geometry. So let's move on. Okay, so think about the sine. The sine, we are restricted from negative pi over 2 to pi over 2. So in other words, we can't come over here. We can only use those two quadrants. So what we need to think about now is, it says the arc sine of negative 1/2. If you remember back in geometry days, when you're doing an arc sine or an inverse sine, that means you're actually looking for the angle. So really what this means is the sine of what angle is equal to negative 1/2. And if you do your fingers, right, and you think about 1/2 is 30 degrees. So if 1/2 is at 30 degrees, that means we need negative 30 degrees. So in other words, the answer would be at negative pi over 6. Okay, that was for A. Let's do B. So for B, we want to know the sine of what angle is the square root of 3 over 2. 0, 30, 45, 60. So it's going to be 60, and it's positive. So positive is going to be at the top. So that means x is going to be pi over 3. Okay, and then the next one is for C, we want to do the sine of what angle equals 2. And so something you need to think about here is that for the sine to be 2, when can the sine be 2? Well, if you think about what's going on here, this is your y value for sine. When you look at the graph of the sine goes like this, and remember, the highest it goes is to 1 and the lowest it goes to negative 1. So therefore, this is impossible. So this is undefined. Can't happen. Okay, this is your checkpoint. So go ahead and pause and come back and see if you got it right. And here's your answers. All right, moving right along. Okay, so see, these are the values for sine, for regular sine. So what we're going to do, usually we would go at 0 degrees, we'd go to 0. At pi over 3, we would go to 1/2. But now, if you notice, everything has flipped around. So our x's are our y's and our y's are our x's. So what we're going to do And we're only going from negative pi over 2 to pi over 2 because that's what we restricted our trig function to. And so at pi over 2, it's going to be 1. And at negative pi over 2, it's going to be negative 1. And then let's pick stuff that's easy. So at pi over 3, so 0 and pi over 3, at pi over 3, it's at a half. So at negative pi over 3, it's going to be at a half, which is right here. And so what you've got now is you have a trig function that looks something like this. We've just flipped it. Okay, it's your turn, so go ahead and see if you can figure this out. Come back when you're ready. Well, actually, this one's just done on the calculator. So if I were you, I would just graph it. So just graph it and then look at it. And what you should see is that the functions should have symmetry with respect to y equals x, because if you remember, that's the inverse. Okay, so now looking at these, this is for cosine, and so cosine, same thing as sine. Cosine, we needed to restrict it because if we do the horizontal line test, it would hit it too much. So this time we restricted it from 0 to pi. So now if the cosine is restricted from 0 to pi, if you look at the cosine, we're going from 0 to pi. And then your domain and your range will flip again, just like it did with the regular cosine. And then with the tangent, you only have to think about one thing with the tangent, because if you remember, the tangent goes from negative pi over 2 to pi over 2. So this was our tangent. And this was negative pi over 2. And this is pi over 2. So all we needed is just that one. So it kind of restricted for us. And that's why all of these definitions come across. Remember, it's restricting it from the place that is closest to 0. Okay, so here, find the exact value of each expression. So what we're going to do is we're going to figure out, this is the cosine. So the first one, we want the cosine of what is equal to the square root of 2 and 2. And remember that the cosine is restricted into those two areas. So it cannot be down here. It's restricted from 0 to pi. So if we want to do pi over 2, that's 45. So the x is going to be pi over 4. It's going to be at 45. So now if we look at the tangent, and remember that the tangent is restricted from, this is for the tangent, whoops. The tangent is restricted from negative pi over 2 to pi over 2. So we're not over here. And we want to find out where the tangent is equal to 0. And the tangent is equal to 0 at 0. So tangent of x equals 0 when x equals 0. Okay, now we want to find out where the arctangent, notice it's written in a different way, but it's the exact same thing. It's just another way to write it. And so we want to know where is the tangent equal to -1. And if you remember using your fingers, where the tangent was equal to 1 was at pi over 4. It's at 45 degrees. So for -1, it would be at negative pi over 4. So wherever you're restricting, you're going to have a positive value and a negative value. Here's your positive value, here's your negative value. So that way you're covering both positive and a negative. That's why you restrict them to those quadrants. All right, so go ahead and pause, see if you can get this one right, and come back when you're ready. Okay, so if you remember that the cosine is equal to 1 at 0 and -1 at pi, so therefore the answer is pi. Okay, moving along, calculators and inverse trucks, and use calculator to approximate the value of each of the expressions. So literally, you're going to plug it in your calculator and find out what the value is. So I don't know if I really need to do this, but so for number 4, and then also one thing you should remember is all of these are radians unless they tell you degrees. So just make sure you're in radians. So for A, you would get -1.453 la 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 la. For B, you get 0.24 7, la 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 la. And then for E, you would get an error. And the reason that you get an error is because it can only go from -1 to 1. So this is undefined, hence the reason you get an error. All right, your turn. Go for it. Come back when you think you have the answer and check your answers. Okay, and here's the answers. And of course, at arc sign, you can't go over -1 or below -1, so -1.1 isn't going to work. Okay, so the composition of inverse functions. So what you want to see here is what we're doing is it's almost like we're doing the composition. Remember or it is the composition. Remember when we were doing this and we did the composition, and the way to find out if the composition was you did the inverse and its function, you should get x. Same if you did the other way, so it's the exact same thing. So with the arc sign, if you remember, our domain is going to be, you're looking at the domain of the inside. That's the function you're looking at. The domain is -1 to 1, and our range is -pi/2 to pi/2. So therefore this would be x. So if you have the sine and the inverse, then it's going to be equal to whatever value is on the inside here. Same thing here. And same thing here. It's going to be x, or it's going to be y. It's almost like these are canceling each other out. So let's go over here and let's take a look at this. The only thing you need to be careful of is you need to make sure that this number is in your domain. So our domain for the inverse tangent is from -infinity to infinity. So therefore the answer here is -5. All right, so let's go to the next one. And we're looking at our domain for the sine, and the domain for our sine function is -infinity to +infinity. So you would think it would be 5π/3. But let's think about what 5π/3 is, because it still has to fit within our range of our arc sign. So because remember that we restricted. So 5π/3 is, let's see, 180/pi. So this is 60. That's 300. And so with our sine, we were restricted from here to here. And therefore, if we were doing 300, we're talking about the 60-degree function. So the answer would actually be, oops, sorry, my pen went out, would be π/3, because that fits in our range. Okay, now for the next one, if we go over here to this one here, we need to think about what is our domain for the arc cosine. And if you remember, we restricted the domain. And so our domain and range flipped. So our domain for the inverse is -1 to 1, and pi is 3.14. So it's not in the domain. Okay, moving on to the next one. All right, cruise on over here, give it a go. Make sure you think about your domains of your functions. Okay, go ahead and pause. Make sure you're in the correct domain and range. Okay, and here's the answers. And the only one that was a little tricky was B. You had to think about where 7π/4 is, and 7π/4 is here. And remember, we're restricted to here, so that means it would be -π/4. Okay, so find the exact value of each of these expressions. So now what we're going to do is we're going to work through these. So what we want to think about is we want to think about what the inside is. So the cosine of some angle is equal to 2/3. So if we think about that, if it's 2/3 and the cosine is restricted between here and here, so that means that my x is 2, and my r is 3. So x is 2, r is 3. I need to figure out what y is. So I'm going to use the my radius, here we go, is 3. So what I need to do is I need to do Pythagorean theorem to find out what my y value is. So y squared plus 2 squared is equal to 3 squared. So y squared is equal to 9 minus 4, which is 5. So therefore y is the square root of 5. So if we're going to find tangent, so the tangent of x would be the y over the x. And the x here is 2. Okay, so now let's think about the next one. And the next one is the arc sine. So the sine of some angle is equal to -3/5. And so if you remember where the sine is restricted to, it's restricted to here. So that means that we are talking about this area here, down here somewhere, where we know y is -3, r is 5. We need to find our x. So 5 squared is equal to -3 squared plus x squared. So 25 minus 9 is 16, which means x is going to be 4. So if we want the cosine, so the cosine of x, or our angle, or theta, or whatever it is we're talking about, cosine is x over r. And there's your answer. Okay, go ahead and give this one a go. Just think about the inside, find your values, figure out what quadrant you're in so you know what your values are. Come back when you're ready. So your answer is 4/5. Again, you had to figure out where you're at so that you know which value is negative. And remember that the tangent is restricted between -pi/2 and pi/2. Okay, so this is the next one, and these are calculus problems. Yes. Okay, so let's go through and work some calculus problems. So if we think about the inside, so the cosine of some theta is equal to 3x over 1. And so the cosine is restricted from 0 to pi. So we know that the cosine is restricted to this area here. So this is x and that's my r. So that means my x, let me go here, my x is going to be 3x, my r is going to be 1. I need to figure out what my y is going to be because I need the sign. So I'm going to say that 3x squared plus y squared is going to be equal to 1 squared. So therefore, I've got 9x squared plus y squared equals 1. So therefore, my y is equal to 1 minus 9x squared. My y squared is. So my y is going to be equal to the square root of 1 minus 9x squared. So if I want to know what sine is, then my sine of x is going to be equal to y, the square root of 1 minus 9x squared, all over your r, and our r is 1. Okay, let's do the next problem, and we'll do the next problem in green. Why not? So here we've got that the cosine is equal to the cosine of some angle is equal to 3x over 1. And this time we're going to want to do the cotangent. Well, we've already figured out what the x is and what the y is. So we know that x is equal to 3x. We know y is equal to the square root of 1 minus 9x squared. And we know r is equal to 1. So if we're looking for the cotangent, that's x over y. So that's going to be the cotangent of our x is going to be x over y. And I wonder, do they go ahead? Nope, they just leave it at that. And you're done. Okay, so now what we're doing is we're just trying to do our vocabulary. So when we look at this, let me do blue. The alternate way of writing this is y equals the sine inverse of x. And then we need to remember that the domain of the arc sine is going to be from -1, which is less than or equal to x, which is less than or equal to 1. Now, for the next one, it'll be y is equal to the arc cosine of x. And again, our range for the cosine is from 0 is less than or equal to y, which is less than or equal to pi, because remember we restricted it. The arc tangent, we can write this as the tangent inverse of x. And then here we need to think about our domain. It's from negative infinity is less than x is less than or equal or is not equal to infinity. Remember, you can't be equal to infinity. And then for our range, it's going to be negative pi over 2 is less than y, which is less than pi over 2. You can't say less than and equal to. Oops, that looks like equal to, because those are vertical asymptotes when you're in tangent, so therefore it can't be less than or equal to. And a trigonometric function has a blank function when its domain is restricted, has an inverse function only when its domain is restricted, because we had to restrict it so that the horizontal line test would pass. And you guys are done.